So our first example, show that the equation given has a solution between -4 and -3. So in order to do that, we're going to put -4 into the equation, work out what value we get as an output, then we're going to put -3 in, work out what value we get. Hopefully one of them will be positive, another one will be negative, and then we can say there's a solution in between these two values because of the sign change. So the first thing we want to look at here is let x equal -4, and we're going to substitute that into here. So 3 plus 5 times -4, take away 2 times -4 squared, take away -4 cubed. And we're going to work out what that is. So this is going to be 3 plus -20. And then we've got take away -4 squared is 16. And then 16 times 2 is 32. Take away, and then -4 cubed. Now -4 times -4 is positive 16. Positive 16 times -4 is -64. So this is, we're going to put this in a calculator. So 3, take away 20, take away 32, plus 64. That gives you 15. So we can see we have to state that 15 is greater than 0. That's just a fancy way of saying 15 is positive. Now we're going to try -3. We're going to hope we get a negative answer to this. So let x equal -3. So let's substitute that into this equation above here. So it's going to be 3 plus 5 times -3. Take away 2 times -3 squared. Take away -3 cubed. So that's going to be 3 plus -15, take away, so -3 squared is 9, 9 times 2 is 18, positive 18, and then take away -3 cubed will be -27. So that becomes 18 plus 27. So let's put that in a calculator. 3, take away 15, take away 18, plus 27. And what you get here is -3. So -3 is less than 0. Now we need to put our actual final answer here, to show that there's a solution. Now we've done the working out, but the statement is what's important. So as there is a change in sign, there is a solution between x equals -4 and x equals -3. So if you were to plot this graph of 3 plus 5x minus 2x squared minus x cubed, then on the graph, somewhere between -4 and -3, the graph would cross the axis. So it might, for example, look like that. It might be the other way around, but either way it crosses through 0 at some point between -4 and -3. Okay, so your turn to try. I've tidied up the working out here, so I've typed it up. I want you to try the question on the right. So show that there's a solution between 1 and 2 for this quadratic. Pause the video, have a go, and then I'm going to show you the answers. Okay, pause the video if you need more time. Here are the solutions. So when you put x equals 1 into your quadratic, you should have gotten -1, and we know that's less than 0, it's negative. When you put x equals 2 into the equation, you get 17 coming out, which is positive. And then this is really crucial. This statement is what you will get marks for, as well as showing this substitution. You have to say, as there is a change in sign, there is a root, or you could also say there's a solution in between these two values. Okay, here's another question for you to try. Use your calculator to help you if you need. Pause the video. Okay, here is the working out. So we can see that if x is 2, we're going to get the square root of 4 plus 4. That's going to be 16. 2 times 2 plus 4. So it's going to be root 8 minus 3, which is negative 0.175. And then when you do the same for 3, you're going to get a positive answer. And then the most important thing, that statement. Because there's a sign change in between the two values, there is an implied solution between them. Okay, another practice question for you to try. Show that this equation has a solution between negative 1.5 and negative 1. Pause the video. I'm going to show the answers in a few seconds. 3, 2, 1. Okay, so you're on for this question. So you can see you should have gotten 0.2426 and so on, and then negative 1. So there's a change in sign, so there's a solution or a root in between these values.